Hi, I'm Youhan Lee. I'm a Kaggler master. So far, I have won 2 gold medals, 1 silver medals, and 5 bronze medals in many computer vision competitions. In this video series, I want to share various techniques for winning medals. I hope these videos help you in winning medals. To win a medal at a computer vision competition in Kaggle, you need to make high-performance model. Of course it is. High-performance model means that the model works accurately for a given task, and it also means that the model is well generalized on both train and test set. Furthermore, the model is good for both private leaderboard score and public leaderboard score. The solution for this is augmentation. All we need is augmentations. With augmentation, we can improve the performance of the model. In other words, model is robust to the unforeseen data, which is different from the training data. Many approaches have been suggested. In this video, I will introduce Cutmix and how to use Cutmix with an example. Cutmix was suggested by Clova AI research in 2019. The title is Cutmix, Regularization Strategy to Train Strong Classifiers with Localizable Features. Let me explain Cutmix with an example. There are pictures of a dog and a cat. It's so cute and lovely. Take a small part of the cat picture. Let's call this part a patch. Then I put it on the photo of the dog. As you can see, we have a new picture. What is the label of this new picture? It can be expressed as adding to each other by the proportion of area occupied by a dog and a cat in the whole picture. Now let's generalize. Let's say the images are X, the dog is A, and the cat is B. A label is expressed by the formula. The size of the patch is randomly selected based on the uniform distribution. This table is from the paper. Compared to baseline performance, this figure shows the performance of various approaches. As you can see that Cutmix performs well for various tasks. Recently, the BengaliAI competition has ended. 2,059 teams attended. 3rd, 5th, 7th rankers used Cutmix, and 2nd team used Fmix, similar to Cutmix. How about using Cutmix in computer vision competition? Let's see how to use it with the code. I made example notebook for this video using BengaliAI competition data. You can see this notebook in our GitHub. I will show how to implement Cutmix in this BengaliAI competition. Okay, let's move to training part. This code creates patches. Within a given size of image, a patch is generated randomly, and the positions of this patch, that is, x, y indexes, are returned. The patch location is chosen uniformly randomly. The width and height of the patch are obtained by multiplying the width and height of the given image by the lambda taken from the beta distribution. Let's check it with an example battery. Let's use the train loader to get inputs and targets. And next, get a lambda and pick random indexes to mix the patches randomly in the batch. In the BengaliAI competition, there are 3 labels, so let's separate target. And let's also make shuffled targets with the random indexes. Next, get patch positions using the randBbox function. And replace the patches of the original input with the patches of randomly shuffled patches. And calculate the area ratio as follows and use it as the ratio of the loss function. Okay, let's see a result. We can see a mixture of two images. Let's get loaded by putting input into the model. Like targets, let's separate loaded into three parts. This is an important part. Loss is the weighted sum of the original targets and the shuffled targets as shown below, where weight is lambda. The final loss is the sum of three losses. Because metric is calculated by ratio of 2:1, multiply the weights as shown below. The code below is a code put together with Cutmix. As you can see, we use Cutmix with 15% probability. We can test how often we use Cutmix by varying the condition. Here. And by adjusting the beta, you can also experiment with the distribution of Cutmix patch size. I hope you get good results using Cutmix. Thanks.